Hello and welcome. This demo is going to show how to configure one of the Digi TransPort routers as an IPsec VPN responder. We'll be working from this scenario where we have a VPN responder router on the left and a VPN initiator over here on the right. This part of the lab will be configuring the left router only, and in today's lab we'll be using a WR44 as the VPN responder. This configuration can be applied to any of the other transport WR routers like the 11, the 21, the 31, the 41 and of course the one we're using today, the 44. There's a little bit of prep work already been done on the WR44 router. I've configured an IP address on Ethernet 0, and this is a public IP address that is accessible from all other devices on the internet. We still need to configure the LAN side network, and we need to configure the IPsec configuration to make it a VPN responder. By the end of this lab and the next one, we'll have a working VPN where we can route between this network on the left, which we call the encryption domain, and this network on the right. This is another encryption domain, and that simply means that when this network over here on the left, 192.168.100.1 or 100.0/24, so anything from the 100 network, needs to communicate with the device over here in the remote network 101. This traffic will be encrypted through an IPsec VPN, and when it gets to this side, the IPsec encapsulation will be removed and the traffic will be routed onwards to the final destination. So if you hear the term encryption domain, it simply means one of the networks that is going to be routable over the VPN. So let's make a start, and I shall show you the configuration that is already applied to this router. Because it's on a public IP address, I have already configured the username and password, so it's not got the default login credentials. If you have a router on a public IP address, then I strongly recommend that you do the same. Okay, so into configuration, network, interfaces, Ethernet, Ethernet 0. This is the WAN side interface with the public IP address. I've applied a description so we have a friendly name so we can see what's going on, and I've selected the option here, get an IP address automatically using DHCP, and my DHCP server is configured to assign this router a public address. Moving into advanced, I enabled NAT on this interface, and I'm using IP address and port. So this configures the router so that any LAN side IP address that we configure, so 192.168.100.something, as that traffic goes through the router and out onto the internet, it automatically has the IP header rewritten so that the source address becomes the IP address of the WAN side interface. IP address and port here is what Cisco would refer to as NAT overload. So you're better off using this option here instead of just IP address only. I've enabled this option to enable inbound DNS blocking. So this stops devices on the internet being able to use this router as a DNS lookup server. The only extra bit of configuration that I did was use this option here, Ethernet hub group. By default, all the Ethernet interfaces on the back of the router are in the same hub group. So that means that if I apply the public IP address onto Ethernet 0, that IP address is in effect available across all 4 interfaces on the back of the router. So when we put Ethernet 0 into its own hub group, the default being 0, so we've now set this into group 1, it means that traffic has to be routed between Ethernet 0 and the other Ethernet interfaces on this router. So that's 1, 2 and 3. I can scroll down and show you that in ETH1 the hub group is 0, ETH2 the hub group is 0, and it will be the same in 3 as well. So now the interfaces on this router are now separated correctly for routing purposes. So that's the pre-configuration already done. Oh, in fact I missed one thing, sorry. I also configured the default route, so that is further down in this page. IP routing and forwarding, static routes, default route 0, and default route 0 is set to Ethernet 0, so that's the route towards the internet. Okay, so back to the top. Network interfaces, Ethernet, Ethernet 1, and now we're going to configure this network here on Ethernet 1. Let's give it a friendly name, LAN interface, and we'll give it an IP address 192.168.100.1. The default mask is correct, we'll keep using that, and we'll hit apply. Notice here it says configuration successfully applied. Click here to save configuration. You don't need to save the configuration every time you hit apply. When you get to a suitable point in your configuration process, so maybe after applying 3 or 4 pages worth of configuration, at that point choose to save, and that will stop you having to go back and reapply any configuration if the router reboots for any reason. On these transport routers, as soon as you click apply, the configuration is live and active. We can have a look at the ETH1 status, and it says it's active but disconnected. This is because there's no Ethernet cable connected to Ethernet 1. If we have a look at the routing table, network status, IP routing table, we can see here that the configuration has been applied, the IP address is active on Ethernet 1. It says it's up, there's nothing physically attached, but that network is now available on the Ethernet 1 interface. The next task we'll do is set up a time server on the router. So if we come into System, Date and Time, the router is already configured to use SNTP to auto set the time, but the SNTP server is to time.devicecloud.com, which is a service provided by Digi. If you prefer to use a more universal time service, like the well-known pool.ntp.org service, where you have regional servers and regional pools available to you, then you can configure this here. I'm going to change mine to 0.uk.pool.ntp.org. I'm going to change the update interval to every 4 hours, and just make sure that check on power up is enabled. When I'm happy, I'll click apply. Moving on to the VPN responder configuration, we're going to go into Network, VPN, IPsec, IK, not IPsec because that's phase 2. We're going to go into phase 1 first, which is IK and IK responder. So phase 1 of the VPN setup is a method of creating a security association or a secure channel between the two VPN routers. This secure channel is created so that the VPN routers can monitor and manage the VPN between themselves securely. In the responder settings, we'll remove the encryption methods of DES and triple DES and just allow the AES methods of encryption, and we'll remove MD5 and SHA-1 for the authentication. We'll allow only MODP groups between 2 and 14. The lifetime for the security association is going to be left at 8 hours. We'll just click apply. So we'll scroll up now into IPsec tunnels and IPsec 0. We'll give it a friendly name, description, so we'll call this VPN with UK WR31.1. The IP address or hostname of the remote unit, you need to set this to an asterisk on the VPN responder, and this tells the responder router to accept an inbound VPN from any IP address. The local LAN, remember we spoke about encryption domains, so the local LAN and the remote LAN, this is where we enter the encryption domains. So the local LAN on the WR44 that we're configuring will be this one, 192.168.100. We're going to put 0 here, /24, and the remote network will be the 101 network. It is possible to configure other networks that aren't directly attached to this router as the encryption domain, and then you can have a VPN which is going to route traffic securely between maybe a network that's connected over here somewhere behind another router or firewall to go through this router and out to the remote. So just because we're using a encryption domain that is directly connected, it doesn't have to be. So the IP address we're going to use is 192.168.100.0 and the mask 255.255.255.0. You also have the option of selecting which interface to use for the local LAN. We could have said Ethernet 1 here. The downside of that is that when you look at the CLI based configuration, it's sometimes not really that obvious which subnet is being used as the encryption domain, because you have to cross-reference this Ethernet 1 with the Ethernet configuration further up. So I always find it a nicer way of doing the configuration by using the actual IP address and subnet mask. So over here we'll be using 192.168.101.0 and again 24-bit mask. The VPN we're configuring at the moment is going to use pre-shared keys for security and authentication of this VPN. Our ID. So the ID that this router is going to use to send to the other side to authenticate and verify the pre-shared key, we're going to use the public IP address. But you could actually just type in here a name. We could type in WR44-HQ and that would go across to the other side. And that would work perfectly fine. You'd normally find that if the router is on a public IP address, you would normally set the IP address as its ID. 82.68.87.5 in my example. You need to change this for your own public IP address of the VPN responder. Remote ID. Now on this lab, I know that my initiator router is going to be assigned a private network address by the mobile operator because it's a WR31 on a cellular or mobile network. That private IP address is going to be subjected to NAT as it comes through the service provider's firewall and NAT router. So the IP address isn't actually going to be known to me. So what we're going to do for the remote ID is we're going to use a name. We're going to use WR31-UK1. So you can see here we've got a mix of IP address and named ID. Encryption to use, we'll use AES-256, we'll use SHA-256 for the authentication, Diffie-Hellman group, yeah, let's go with 5, it's fairly common now. Because this is a VPN responder, it's not going to be in charge of bringing the tunnel up. That's the job of the initiator. So we'll leave this to bring the tunnel up on demand. And if the tunnel is down and a packet's ready to be sent, well, again, the initiator should be managing the tunnel status and keeping it up all the time. So we'll leave this on, drop the packet. We'll change the phase 2 lifetime to 4 hours, but we won't worry about the lifetime in kilobytes. Click apply. The last step within the VPN configuration is to configure the pre-shared key. So we mentioned about the IDs being sent from side to side to verify the pre-shared key. So this is the ID here that we need to configure on this router. So what this router will do, it will look for the initiator sending its ID, which is hopefully this one, WR31-UK1, and it will use that to cross-reference the pre-shared key. So I'm going to copy this, go into security, users, 10 to 19, user 10, and in here paste that ID. I've gone for a user 10 rather than anything here, user 0 through to 9, because by default user 10 has a low access level. Anything with a user 0 through to 9 will have a super access level. So if you forget to change this, then it's not anything too major, but ideally you should set this to none. So this is the management access level for anyone that tries to log in with this username. So the pre-shared key is set here as the password, which I have got already typed out in Notepad. Add that and confirm it and click apply. Looking at advanced, there are options here for alternate IK key. Do not configure these. These are not for the pre-shared key. These are for when it comes to changing a pre-shared key when a VPN is already configured and up. For a regular VPN configuration, these are not needed. So if you have already seen these, they don't need to be configured. Okay, so we've applied that configuration. The next thing we need to do is to enable IPsec on the WAN interface. So now we've configured IPsec, we've configured phase 1, phase 2 and the pre-shared key. To allow VPNs to be built into this router, we have to come into the WAN interface, which is Ethernet 0, into advanced, scroll down and enable IPsec on this interface. Scroll down a bit more, click apply. So this router is now ready to accept inbound VPN negotiations. The last thing I recommend that you do is enable the firewall on the WAN side interface. So every transport router has a default set of firewall rules included as standard. Very briefly, the rules will allow FTP traffic through the router. They will allow all traffic from the LAN outbound to the internet, and they will allow traffic generated by the router itself. So for example, the SNTP server we configured at the start of this lab, this rule will allow traffic generated by the router itself out and the replies back in. The next set of rules allow IPsec VPNs to be created to this router, and then the next few rules here allow for secure management of the router. Finally, anything that doesn't match one of the configured rules will be blocked. Before I enable this firewall, I need to make sure that I don't lock myself out of this router. So I'm going to insert a rule at the top. Anything with a hash becomes a comment. Allow local network to access router. And then I'm going to insert a rule below that. Because I'm accessing this router via its WAN interface, I need to make sure that my local network is still allowed to communicate with the router, because at the moment I'm not using HTTPS, I'm only using HTTP, so that traffic would not be allowed into this router for management. So I'm just going to allow my whole local subnet to manage the router. So pass in break end on ETH0 from 192.168.1 my local network 0.0/24 to ADDR-ETH0. So this is a placeholder that says replace this placeholder with the actual IP address of the Ethernet 0 interface. So that's the public address. Inspect-state. So it's a fairly wide rule, but it's fine for this lab. If this was a real live network, then I wouldn't really be allowing everything in. I'd be more specific, but for a lab, it's fine. The next thing is to click on the save button down here, and this will save these amended rules to the fw.txt, which is a file stored on the router's flash, where these rules are saved to. To enable the firewall on the WAN interface, Ethernet 0, I just scroll down a little bit, pop the check mark next to Ethernet 0 to say that we want to enable the firewall on this interface. Scroll down, click apply. Note that as soon as you click apply, the configuration change takes immediate effect. So if you've got anything wrong on this firewall rule set, potentially you're going to end up locking yourself out of the router. So before you click apply, make sure it's right. Let's scroll back up so we can see here it says hits, and they're all 0 at the moment. If I refresh this page by clicking on firewall, we now see that there's 229 hits on this rule, allowing management traffic from my local network to the WAN interface. There's also a bit of other traffic on there being generated by the router, and that's fine. You expect to see that. So that's the main part of the configuration complete for this lab. Let's go and save the configuration. So administration, save configuration, and we'll just click this button up here to save, and that saves the configuration to the flash, to a file called config.da0, and the passwords will be in a password file called pwds.da0. We'll apply that, sorry, we'll OK that, then come to execute command. If we type in here config c show, this is a CLI command that will show us the commands that or the configuration that we've applied, which we can quickly run through. So we've got the Ethernet 0 configuration, which is the WAN interface. Ignore this IP address here because the DHCP client is enabled. NAT is enabled, group 1 is the hub group, IPsec is enabled and the firewall is on, and we're blocking DNS. Ethernet 1, we applied an IP address. Notice that the subnet mask isn't shown here on either Ethernet 0 or Ethernet 1. That's because by default the subnet mask is 255.255.255.0 on the interfaces. So when you apply the configuration, if you don't see the mask here, it means it's because it's already the default value. The default route is via Ethernet 0. This is the equivalent of the IPsec configuration in the GUI. We've got the SNTP server that we configured at the start, and here we've got the Phase 1 IKE configuration. A little bit further down, you'll see here we've got user 10 configured with the name WR31 and the password. Now this isn't the plain text, so this obviously doesn't look like what I typed in, although you can't see what I typed in. Anything that's prefixed with so password, means it's the enciphered version of the password. So that's configuration here complete. We've configured the LAN side interface, and we've configured this router as a VPN responder ready to accept VPN negotiations from our WR31 that we'll be configuring in the next lab. I hope you found this useful. Thank you for watching.